Tesla can't match this number. Volkswagen can't match it. Ford doesn't have an answer yet, not a slower version. Not a rival prototype, nothing. 9 days before this video, an engineering team in Wuxi, China, walked onto a stage and introduced a silver box the size of a suitcase. Nobody outside the industry was watching. No live stream went viral. No headline broke through the usual noise of Chinese tech launches that turn out to be nothing more than a press release with extra steps. But inside the auto industry, this one landed differently. And it landed fast. By the time Western factories fully understand what's inside that box, cars running this technology will already be on roads across Europe, Latin America, and Africa. Every road except yours, for now. If you want to know exactly why some of the biggest names in the auto industry went quiet after that stage, stay for the whole video. Wuxi, China, July 16, 2026. A launch event inside Infimotion's own headquarters, the Geely-owned drivetrain supplier, stepping into its first public spotlight as an independent company. This isn't a startup with a slide deck and no track record. In 2021, Infimotion built China's first self-developed 400-volt silicon carbide drive unit for the Zeekr 001. In 2024, it shipped the world's first 11-in-1 domain-controlled drive unit, already clearing 90% CLTC efficiency. In 2025, it released the world's first mass-produced magnesium-aluminum dual-motor unit. By mid-2026, it ranked among China's top 3 suppliers for both motors and inverters, already supplying Geely, Volvo, and Jaguar Land Rover. Every one of those milestones was a warm-up. On a rotating pedestal at center stage sits a rectangular silver unit, about 165 pounds, that looks like nothing special. Then Infimotion CEO Joe Lin gets to the number his engineers had spent years chasing, and 93.8%. Comprehensive drive efficiency, verified on China's KLTC test cycle, and according to Infimotion, a production record for any electric drivetrain on Earth. By that evening, engineering teams at rival automakers were quietly picking the announcement apart, line by line. Because a number like that doesn't stay contained to one press release. It reshapes a spreadsheet every EV maker on the planet is currently working from. Here's why that single number actually matters to you if you're anywhere near buying an EV in the next few years. Think of your battery as a bucket of water. Every time you hit the accelerator, you're pouring that water down a pipe toward your wheels, except the pipe has holes in it. Some leaks out as heat, some as vibration, some gets lost to friction inside the motor housing. By the time it reaches the wheels, you've lost a real chunk of what you paid for at the charger. That loss has a name, efficiency loss. And it's the quiet, invisible tax on every electric car ever built. Here's how leaky even the best cars on the market actually are. A Tesla Model S Plaid, arguably Tesla's most efficient production car, runs around 90 to 92% efficient. Volkswagen's ID.4 sits closer to 89. Ford's F-150 Lightning drops to roughly 87 in real-world driving. Worse in cold weather, since heating a cabin and a battery pack both eat directly into range. Even BMW's flagship electric SUV tops out around 91. Every one of those cars is quietly losing somewhere between 8 and 13% of your battery to nothing at all, the entire time you're driving. Money you already paid for at the charger and simply never get to use. Infimotion's new system, branded Thunder, loses just 6.2. That gap isn't a spec sheet curiosity. Stretched across a full battery pack, it's the difference between roughly 350 miles of range and 370. Multiply that gap across 10 million cars on the road, and the entire cost structure of the global EV industry shifts underneath every manufacturer at once, whether they're ready for it or not. So what did Chinese engineers actually figure out? Picture your kitchen, a refrigerator in one corner, a microwave over the stove, a dishwasher under the counter, 4 separate appliances, 4 separate motors, 4 sets of wiring. Messy, but it works. Now imagine someone tells you they can build one machine, the size of your microwave, that does everything all 4 appliances do combined, using less power than any single one of them alone. You'd assume they were exaggerating. Then you'd watch it work, and your old kitchen would suddenly look cluttered and obsolete. That's roughly what Infimotion just did to the electric drivetrain. A typical EV scatters 12 separate electronic systems across the chassis, the motor controller, the DC-DC converter, the onboard charger, separate battery management and thermal systems, each in its own housing, each wired in individually through the floor and firewall. Thunder fuses all 12 of those hardware systems, plus 4 intelligent software layers into a single magnesium alloy unit built for extremes, rated across a temperature range from -60 to 140 degrees Celsius, and put through more than 9,000 validation tests and roughly 5 million kilometers of road testing before that stage in Wuxi ever happened. 16-in-1 isn't a marketing name, it's a literal parts count. Over 180 individual components deleted from the design entirely. High voltage wiring cut by 30%, low voltage wiring cut by 15%. What used to be a sprawling mess of boxes and cable runs is now a single 75-kilogram unit. And every one of those 180 deleted parts is a warranty claim that no longer exists. A connector that can't corrode. A fan motor that can't seize on a highway 5 years from now. Then there's the output. And this is where the number stops being merely clever and starts being genuinely uncomfortable for rival engineers. The Galaxy TT, the sedan Thunder debuts in, ships in 2 configurations. The base rear-wheel drive version makes 245 kilowatts, around 329 horsepower, already a strong number for a mid-size electric sedan. The all-wheel drive version combines a front and rear motor for 425 kilowatts total, roughly 570 horsepower, running on an 800-volt architecture built for genuinely fast charging, with a 0 to 100 kilometers per hour time of 3.8 seconds. Supercar territory, on the same platform Geely uses for its cheaper trims. Here's the number that made engineers reach for calculators. Infomotion states a power density around 11.8 kilowatts per kilogram, close to 16 horsepower per kilogram. Multiply that against the unit's 75-kilogram weight, and you land near 1,200 theoretical horsepower for the fully integrated drive unit itself, a figure several outlets covering the launch did the same math on independently. That's not the confirmed output of any production car Geely is selling, it's a ceiling the architecture is now capable of reaching. Even the confirmed, real-world 570 horsepower figure already beats the power-to-weight ratio of anything Ford, Volkswagen, or GM currently ships in a production EV. And Thunder isn't waiting years for a showroom. Sister brand Lynk & Co. is expected to beat the Galaxy TT to market with it, folding a version of the system into its updated O2, sold domestically as the Z20, arriving in the third quarter of 2026 with a 329 horsepower motor. This isn't a concept car promise, with a vague 2030 timeline attached. It's weeks away. Slide decks are cheap though, so Geely backed the claim with something harder to fake. It sent a Galaxy TT around Qinghai Lake, a brutal high-altitude endurance route in western China, with Guinness World Records officials physically on site, timing and measurement equipment bolted directly to the car. Result, 8.2 kilowatt-hours consumed per 100 kilometers, roughly a third of what a typical American EV burns over the same distance in real-world conditions. Certified, on-the-spot first world record. Then Geely did something that looked almost like showing off. 2 Galaxy TT sedans, wet asphalt, instructed to drift continuously side by side for as long as the cars could physically hold it, the kind of sustained thermal load that cooks motors and batteries within minutes on ordinary production cars, the kind even dedicated race machinery struggles to survive. The 2 cars reportedly held a continuous, synchronized drift for well over 40 kilometers straight, never overheating, engineers on the sideline watching temperature gauges that simply refused to climb. Second Guinness record, in a category Guinness had to create on the spot because no production vehicle had ever attempted it. 2 world records in 1 week, from a suitcase-sized engine almost nobody outside the industry had heard of 9 days earlier. Now, here's the part most coverage of this story quietly skips, because it complicates a clean headline. Not everyone who watched that Wuxi presentation walked away fully convinced, and it's worth sitting with why. The 93.8% figure is a CLTC number, China's own domestic testing standard, and CLTC is notoriously generous compared to the EPA cycle America uses, or the WLTP cycle Europe uses. Outlets covering the launch, including Car News China and Car Scoops, flagged exactly this caveat in their own coverage. China has produced a real string of genuine battery and drivetrain breakthroughs over the past 5 years, but it's also produced numbers that looked incredible under CLTC, and shrank noticeably once independent labs got their hands on a production unit under stricter Western cycles. That history is exactly why engineers outside China default to caution first and excitement second, even when the underlying engineering, like the physical deletion of 180 real components, is something you can independently photograph and weigh. The Qinghai Lake Run and the drift record are real, independently timed by Guinness officials, and that part isn't in dispute. But both runs happened on a closed course, under conditions Geely itself selected and controlled from start to finish, which is a meaningfully different thing from third-party testing on public roads in ordinary weather. None of that makes the 16-in-1 integration fake. Outside journalists have already torn a unit down to individual bolts and confirmed the component deletion is real engineering, not a marketing trick. But the honest version of this story carries an asterisk most headlines strip out. The number that stunned that room in Wuxi still has to survive contact with independent Western testing labs before rival engineers stop being nervous and start being genuinely afraid. The most telling reaction to all of this wasn't a competing announcement. It was silence. And silence from a multi-trillion-dollar global industry that usually can't resist a press release rebuttal within 48 hours is its own kind of admission. Volkswagen, the world's largest automaker by volume, said essentially nothing publicly. Its most advanced integrated drive units still hover around 89% efficiency, a full 5 points behind what just landed in Chinese showrooms, and VW is already paying Chinese software company XPeng to help develop its next-generation EV software, itself a quiet admission of where the engineering lead has shifted. Volkswagen's China sales have been sliding for years, down by more than half from their 2019 peak. Ford may be in the worst spot of any legacy automaker. The F-150 Lightning, its flagship electric truck, has struggled with real-world reliability and demand since launch, has already shed a steep share of its resale value, and executives have reportedly discussed pivoting more of the truck lineup toward hybrids instead of doubling down on the current EV platform. General Motors booked roughly $6 billion in EV-related write-downs in 2025 alone, on top of billions more written down the year before that. In its most recent quarter, GM's EV sales fell sharply across nearly every nameplate it sells, and the Hummer EV's sales specifically fell nearly 57% year-over-year, with the Silverado EV sitting largely unsold on dealer lots waiting for buyers who increasingly aren't showing up. Neither company has publicly addressed Thunder by name. That silence, from two automakers that used to announce a press response to a rival's slide deck within 48 hours, says more than any statement would have. Even Tesla, whose most efficient car still trails this new benchmark by several points, lost its title as the world's largest EV maker to China's BYD back in 2024. And Tesla's own exports out of China have been sliding as domestic competition intensifies. Detroit's collective share of the global auto market has been shrinking for years, while Chinese automakers' global share keeps climbing. A shift industry analysts describe as happening quietly, one quarterly earnings call at a time, rather than as any single dramatic event. And Thunder isn't an isolated flex. BYD is chasing its own headline this year, sending the Yangwang U9 Extreme back to the automotive testing Papenburg track in Germany in November, aiming to beat the 496 km/h production car speed, record its own car set there the year before. Different company, different discipline, same underlying message. Chinese manufacturers are increasingly competing on raw engineering depth, not just on price. And Thunder is simply the version of that message aimed squarely at everyday buyers instead of speed record chasers. Now picture the decision this technology actually forces, thousands of miles from any boardroom, in a place none of these press releases were written with in mind. A fleet operations manager in Lagos, Nigeria, is looking at a proposal on his desk this week. A Chinese distributor wants him to commit to 40 Thunder-powered delivery vans, replacing his aging diesel fleet at a price well below anything Ford or Volkswagen currently quotes for a comparable electric van in his market. He's not an engineer. He's not going to fly to Wuxi and inspect a dyno. He has no way to independently confirm the 93.8% figure. No lab anywhere in West Africa can run an EPA-equivalent test cycle, and the nearest facility that can is thousands of miles away, on a different continent, with a waiting list. If he signs and the technology performs anywhere close to advertised, he cuts his fuel and maintenance costs nearly in half and becomes the operator who modernized years ahead of every competitor bidding on the same contracts. If he signs and real-world efficiency lands closer to the low 80s once his vans are running through Lagos heat, humidity, and traffic instead of a controlled Chinese test loop, he becomes the story other fleet managers quietly bring up at industry conferences for the next decade, the guy who bet the fleet on a number he couldn't verify. That exact bet is being weighed right now in fleet offices across Africa, Latin America, and Southeast Asia, markets with no tariff wall to hide behind, where the decision isn't philosophical, it's a spreadsheet with real fuel and payroll numbers attached, and nobody signing those contracts gets to wait 18 months for an independent lab to settle the argument first. So here's what this actually means for you. First, Chinese EVs are about to get meaningfully cheaper, regardless of exactly where the fully independently verified efficiency number eventually lands, because deleting 180 components deletes manufacturing cost, assembly labor, and long-term warranty risk all at once, and none of that math depends on the 93.8% figure, holding up perfectly under a Western test cycle. Second, if you buy a non-Chinese EV today, you may be paying premium pricing for an architecture the industry has functionally started treating as a generation behind, even while engineers are still arguing over exactly how far behind, which means the discount you're not getting today could show up as a resale problem in 3 or 4 years. Third, resale values on existing Western EVs are likely to get rougher before they get better. The F-150 Lightning and Silverado EV have already lost a steep share of their value in just a couple of years, and cheaper, longer-range Chinese competition arriving between 2028 and 2030 won't help that trend, verified numbers or not, because used car buyers respond to headlines and comparison charts long before they respond to independent lab reports. Fourth, tariffs currently shield American buyers from this shift, but almost nobody else on the planet has that shield. Europe, Latin America, Africa, and Southeast Asia are the live, real-world testing ground for whether 93.8% survives contact with actual roads, actual weather, and owners who never drive on a closed course in Western China. And whatever those markets learn over the next 3 years will eventually make its way back to a dealership near you, tariff or not. The Western auto industry has roughly 3 years to either match this architecture or build a credible public case for why it doesn't need to. That clock started on the morning of July 16, 2026. Regardless of whether the number that started it holds up exactly as announced once labs outside Geely's own control get their hands on it. A quiet stage in Wuxi. A silver box the size of carry-on luggage. One number that stopped a room cold. And one honest asterisk still hanging over all of it, waiting on an independent lab somewhere outside China to confirm it, or quietly deflate it over the next 18 months. 10 years ago, Chinese cars were dismissed as knockoffs nobody serious would drive. 5 years ago, Chinese batteries were dismissed as good enough for buses, but not for anything that actually needed to perform. Today, a Chinese supplier most car buyers had never heard of a month ago is setting the number the rest of the global industry has to either match or publicly explain away, and it did it with a box you could carry through an airport. Whether 93.8% turns out to be the real future of driving or simply the most convincing test track number of the decade is still being decided right now, in fleet offices in Lagos, in engineering labs in Wolfsburg, and in boardrooms in Detroit that have gone unusually quiet since July 16th. Which side of that bet would you take? Drop it in the comments.